Hello, I'm Sankar. Today I'm going to demonstrate to you how to conduct a soil compaction test in order to determine the maximum dry density and the optimum moisture content of a given soil sample. Soil compaction test is an economical way to improve the soil conditions. You can use soil compaction to make suitable ground for embankments, roads, as well as placing soil fields and earth dams. So the extent of the soil compaction depends on the effort you put into compaction as well as the moisture content of the soil. Different standards are there differing the compaction effort as well as the amount of energy input into the compaction. So that means the the maximum dry density of a soil sample and the optimum moisture content are not soil properties. I'll introduce you the equipment that we are going to use today. Most importantly, this is our soil sample we're going to use, and this is the standard Proctor compaction hammer, which is 2.5 kilograms heavy, and this is our compaction mold and as well as the top collar, and we are going to use a straight steel edge and graduated cylinder and small cans to determine the moisture content, and a large spoon and a large tray to mix the soil. As the first step, we are going to measure the weight of this mold without the collar. So place it on the scale and measure the weight. That's 3.87 kilograms. Then we are going to measure 2.5 kilograms of soil from the sample given to us to determine the maximum dry density. So first, place the tray on the scale. Make sure you set the reading to 0 and then place soil on the tray and determine the weight of the soil sample. Remove any extra soil and measure only 2.5 kilograms of soil exactly. The moisture content is weight of water divided by weight of soil, and we assume that at the lab condition moisture content is about 2%. And we have the soil sample of 2500 grams, and we'll calculate how much water it's already in there. So the total weight is W, that's equal to weight of water and weight of soil. Weight of water is equal to 2% of the weight of soil, so this would be 0.02 weight of soil plus weight of soil, and this whole thing is equal to 2500 grams. And from that you can calculate that weight of soil is 2451 grams and weight of water is 49 grams. We want to make the moisture content in this soil sample 8%. So in the first sample, M is 8%. For us to make it 8%, we have to add extra water. So let's calculate how much water we need in order for the soil sample to have 8% moisture content. So weight of water would be M into WS. This is 0.08 multiplied by 2451 grams. This is equal to 196 grams. And we need extra water, so 196 minus 49, which we already have, and this is equal to 147 grams of water for the first sample. Okay, so when you do the compaction test, you will be divided into two groups. One group will conduct the standard Proctor compaction test using the standard Proctor compaction hammer, and the other group will conduct the practical using the modified Proctor compaction hammer. The difference between the two is you use 5 layers in modified Proctor compaction and 3 layers in standard Proctor compaction test. For each layer, for each test, you use only 25 blows. So we have the soil sample. Now we are going to make the moisture content of the soil sample 8%. We need to add 147 grams of water as per the calculation we just did while ago. That equals to 147 milliliters of water. You can use the graduated cylinder to measure 147 milliliters of water. Gently add the water into the middle of the soil sample and mix it well until the texture is constant and uniform throughout the soil sample. Alright, so once you mix the sample to a uniform texture, you take the compaction mold, place the collar on top of that, and place soil inside the mold. You have to compact the soil sample in 3 layers, so make sure you place enough soil in the mold so that once you compact the first soil layer, it would come up to 1/3 of the mold. And now place the mold on some hard surface and using the standard Proctor compaction hammer, compact the soil sample. So when you compact the soil sample, you have to use 25 blows evenly around the soil surface. Make sure that you place opening of this hammer here against the inner surface of the mold, and rest the mold on top of the soil. Hold it from the neck of the hammer, raise it all the way up and release it, and then move to the other side and repeat. Likewise, you first compact the 4 diagonal corners and then go around the surface compacting with 25 blows. That's 4. Now I'm going to compact around the sample with 25 blows all together. 25. Once you compact the sample, add some more soil and compact the second layer. Once this soil layer is compacted, the mold should be filled up to 2/3 of its capacity. Once you finish all 3 layers, remove the collar here and gradually lift it, and you should have little bit of soil above the mold so that you can trim off the top of the soil sample and have a perfectly leveled soil sample to calculate the maximum dry density. So use the steel straight edge and trim off the top of the soil sample. Make sure you do not remove chunks of soil from the soil sample, otherwise you'll have to do it from the beginning. Now clean any loose soil from around the mold. And measure the weight of the mold with the sample. So place the mold with the sample on the scale and record the weight of the mold plus sample weight. That's 5.696 kilograms. So now we are going to take the soil sample out of the mold using the extractor here. I'm going to remove the base plate of the mold. Take the sample and place it in the extractor. Make sure the mold is in the middle of the extractor. And using the jack, you can lift up the soil sample. What we do next is we use 2 small cups and extract 2 small soil samples from the middle of this big soil sample and use the oven to dry those and calculate the moisture content of the particular sample. We first have to measure the weight of these cups. Make sure those are numbered. You can split the sample into 2. And extract 2 small soil samples from the middle of the sample. And now you have to measure the wet soil plus the small cup weight. Once you have those readings, you have to make sure that these cups are kept inside an oven for 24 hours. Let the soil samples dry out and then you take this out and measure the weight again. That would be your dry soil plus cup values. Difference between the wet soil plus cup and the dry soil plus cup is your water weight in the small soil sample. Use that value to calculate the actual moisture content of the soil sample we just tested. Now for the second sample, we want to make the moisture content 12%. So now the weight of water should be M into WS, that's 0.12 multiplied by 2451 grams, and this is equal to 294 grams. So extra water needed is 294 grams minus 196. That's because that's what we've already got, and this is equal to 98 grams of water. Likewise, we have to increase the moisture content to 16%. That's because we increase the moisture content by 4% each time. It would be the same amount of water we are adding for each sample. Okay, we have the sample of soil with moisture content about 8%, and we are going to make it 12%. So what I'm going to do is I'm going to break down the sample from the previous step and add 98 grams of water so that it would have a moisture content roughly around 12%. Okay, so once you complete all 4 samples and place the small dishes with the wet soil samples in the oven, we can do a rough calculation and see how the dry density works out. I'll just do an example calculation for the first soil sample. So if you have a look at the lab notes, and this is how you fill the table number 12. So M1 we have already measured, that's 3,870 grams. M2, this is the weight of soil, mold plus wet soil, 5,696 grams. And mass of wet soil, that's M2 minus M1, this is 1,826 grams. And the standard mold volume, that's VM, is given, that's 1000 cubic centimeters. So the bulk density, that's rho B, this is M2 minus M1 divided by VM, and this is in grams, this divided by 1000 cubic centimeters, and this will work out as 1.826 tons per meter cube. Assuming that our moisture content value is 8%, we can calculate the rest of the calculations in data sheet number 12. So dry density, that's rho D, that's equal to bulk density divided by 1 plus M, this is equal to 1.826 tons per meter cube divided by 1 plus 0.08, and this value is 1.691 tons per meter cube. Once you have the actual moisture content values based on the oven dried sample, you can work out the actual moisture content value, and then from the bulk density you can calculate the relevant dry density of the soil sample. Okay, now we've kept all those small cups with wet soil samples in it in the oven for 24 hours, and now we're going to take this out and measure the dry weight. Make sure you use oven gloves to take the cups out. It's really warm. Alright, so once the cups are cooled down to room temperature, you can take the dry weight of the sample. So just make sure you take down the proper readings and write down the dry soil plus the cup value against the correct cup number. Okay, so once we have all the measurements from small cups, wet soil plus container values, and the dry soil plus container values, we can calculate the actual moisture content for each sample. So I'm going to show you how to calculate the moisture content for the first sample. So the wet soil plus container weight, we measured it as 44.30 grams, and the dry soil plus container weight is 42.70 grams, and the container weight we measured it as 20.40 grams. So the dry soil weight is the dry soil plus container value minus container weight, so that's 42.70 minus 20.40 grams. This is equal to 22.30 grams. And the weight of water is wet soil plus container value minus dry soil plus container value. So that would be 44.30 minus 42.70 grams, and this is 1.6 grams. Now the moisture content is the weight of water divided by weight of dry soil. So our M value is weight of water divided by weight of soil. So this is 1.6 divided by 22.30. This is equal to 0.072, and this is the moisture content value 1 for first sample. We have 2 cups, that means we can calculate 2 moisture content values for the same sample. What we do is we average those 2 values and then use the average value in the calculations. Okay, now we have the bulk density for the first sample, that's 1.826 tons per meter cube, and we also have the average moisture content value for the first sample, that's 0.076. From these two we can calculate the dry density, that's rho B divided by 1 plus m. This is 1.826 tons per meter cube divided by 1.076, and the dry density for the first sample would be 1.697 tons per meter cube. Once you calculate the dry density for all 4 samples, you can plot the water content versus the dry density graph. So it would be something like this. You draw a best fit curve for the points, and the peak here will give you the maximum dry density and the relevant optimum moisture content. You have to calculate all 4 dry density values and complete the data sheet number 12 and plot this graph before you leave the practical. For assessment criteria and the reporting style, please refer to the lab note. Thank you.